In this video, we are going to take a look at two different types of symmetry. So one type of symmetry that we might see is symmetry about the y-axis. If a function happens to have symmetry about a y-axis, then we call it an even function. And so y-axis symmetry, that means that our values to the left of the y-axis are exactly the same values as to those to the right. And so here we have some y-axis symmetry. The way it looks in a function, or as in some function notation, the way we could verify it if we can't look at the picture is we can take our function, plug in negative x for all of the x values, and see what happens. If it turns out that the function at negative x is exactly the same as the function at x, then we have an even function. So the idea here is if we have some value back here at, say, -2, whatever that function value is at -2, it should have the exact same function. So the function value at -2 is exactly the same as the function value at +2. So that is an even function. That should be true for every single x. So we would, if we need to show that, we will show it in general. We won't pick specific x values. We will just plug in negative x to the function and see if that negative somehow magically goes away. We could also have symmetry about the origin. That's an odd function. So for odd functions, you have symmetry about the origin. So this would be an example of an odd function. In our function notation, we would say f of negative x is equal to the negative of f of x. So if we go back to, then our function value down here is exactly the opposite, has exactly the opposite sign as the function value up here. All right, so this might be 2, 8, and then this is -8. So our function value down here has exactly the opposite sign. So let's look at some examples and see if we can identify whether the functions are odd, even, or neither. So how do we do that if we just look at the function, if I can't see the graph? So the way that we do that, in both cases, we are going to evaluate our function at -x. So what does f of -x mean? It means in the function we are going to replace x with -x everywhere. So -x to the fourth, that's the same thing as -1 to the fourth times x to the fourth, minus 2 times -1 squared times x squared. What is -1 to the fourth? Well, if you raise a negative to an even power, the negative's going to go away, and 1 to the fourth is just 1. So this leaves us with just x to the fourth. -1 squared is also +1, so you have 2 times 1, which is still just the 2, x squared. What do you notice about this? This is exactly the same as the original function. So when we plugged in that -x, the negatives just magically go away. Because of that, we have an even function. Let's look at this next example. So here we have x minus 1 squared. So we are again going to replace our x with -x. So what can we do there? Well, here we can't do the -1 in quite the same way, although we can do something a little bit similar. We can write this as -1 times x plus 1. So before we're squaring it, so we could factor out a -1. And then we could write it as -1 squared times x plus 1 squared. What happens to that negative? That negative is going to go away, and we are left with x plus 1 squared. Is that the original function? All right, so is that x minus 1 squared? No, because there's a plus here, there's a minus here. So that's not the original function. Is this the negative of the original function? And the answer there is also no, because a negative would just have a negative out in front of it. So not just changing the sign here, it would actually be a negative out in front of the whole thing. And so this function is neither odd nor even. And our final example, if we were to look at this function down here, f of x is equal to x cubed plus the cube root of x. We're going to replace our x with a negative x, and then we're going to follow that through and see what happens. So if we take negative x cubed, that's the same as -1 cubed times x cubed. The cube root of negative x, can we take a cube root of a negative? We sure can. We can take odd roots of negative values. So this is the same as the cube root of -1 times the cube root of x. All right, so what's going to happen with our -1 cubed here? Well, that will become just a -1, so we're left with just a negative x cubed. The cube root of -1 is also -1, so we're left with just a negative cube root of x. Is this right here our original function? No. It's clearly not the original function. This has a minus here where it was plus here. Is this the negative of the original function? Right, so the negative of that original function is the negative of x cubed plus the cube root of x. So that negative gets distributed. Oh, yeah, so this right here is in fact equal to the negative of f of x. So that makes this an odd function. Those are the big ideas from this section. We will talk to you again later. Have a good one.